let's look at a problem that isn't throwing things up in the air. Let's look at a problem. Because really, I mean, 2D kinematics is all about throwing stuff, right? It's all about ballistics, it's all about projectile motion, it's all about okay. The fact that X, number one point of 2D kinematics is motion in X and Y directions are independent of each other. That is, what happens in the y direction, function of y, t, does not depend on x as a function of t. And so vy as a function of t also does not depend on vx as a function of t. The acceleration in the y direction does not depend on our acceleration in the x direction. There, however, everything is connected with time. Okay. For the second part of today's quiz, you would actually need to use the fact that we would need to use delta y is equal to y initial minus v t plus vt minus g over 2 t squared. Where this v now would be coming from v at b. So v at b. And then we would simply solve for t. Solve for t. Okay. And one thing that I have been, that keeps confusing me, that hopefully isn't confusing you, is when we write the kinematic equation, okay, say delta y is equal to vy t plus 1/2 a t squared, or we can write this as 0 equals negative delta y plus vy t plus 1/2 a t squared. When you're doing your quadratic equation, we normally write the quadratic equation a x squared plus bx plus c equals 0. Okay, this is the normal way that we write it in algebra. And you gotta make very clear that this is written backwards, okay? This is 0 equals c plus bt plus at squared, okay? So this is something that I keep having to slam the brakes on and look at it twice, is we're writing it this way, you probably used to seeing it this way, okay? So it might actually, it might actually help you that every time we use the quadratic equation, write it out. Write it out in a way that's familiar to you. Use what you already know, okay? and then rearrange it so that it makes sense in our context. So in the most general form, we have t, okay, so t squared, or t is equal to negative v initial plus or minus square root of v naught squared minus 4 a over 2 times delta y. Right. That's all over 2 a over 2. So that gives us negative v naught plus or minus square root of v naught squared minus 4 a, no, minus 2 a delta y all over a. Right? So this is the most general form, right? Either memorize this, put it in your notes 5 or 6 different places, okay? This is the general form. This is the most general. Most general. This is when we don't, this is when we, most genial? Okay, most general. It's also the most genial. General, okay? Let's see, any more places where we're going to find ourselves? Question?
We can back it up a little bit to where you were talking about solving for time using the delta y equation over there.
Right.
Right. Why do you want to do v at b and not v initial if our x is equal to our velocity in x direction times the total time? If we use that, doesn't that really
That's a darn good question. Thing is, you could do this either way. You could either start with your initial velocity here, or since we know it's the same over here, we can use the same velocity over here. Yeah, I see where you're going. I see what you mean. Let me parse this out a little bit. Okay. That may not have been the wisest thing for me to say. So let me make sure that that's. So yeah, this will work for whatever your initial velocity is. You can take that at any point, and at this, so we know the velocity, we know v naught here, we know v naught here, and we know v naught here. We can use any one of these three. Okay, but it's from here to here that gives us our total delta t. Okay, so that'll give us our total delta t. And if we know our total delta t, this will give us our total delta x. Okay. What about in situations where okay, so if we have velocities, there's just not that many problems where they're going to ask you what's the final velocity. Some things will need that. Mostly we're concerned about time or total distances, but yeah, velocities. Let's see. See if we can figure out another problem where we would use v squared minus v naught squared is equal to 2a delta x. By the way, this also you can also get this from conservation of energy, but which we might I will probably talk about conservation of energy before the class is all done. But for right now, we can look at the fact that, okay, we just did a substitution of our velocity equation into our position equation and got an equation relating the two of them. And this, of course, is under constant acceleration. All of this stuff is under constant acceleration, all right? We're not going to give you a problem. Okay, some joker someday is going to give you a problem where they tell you what the acceleration is as a function of time. At that point, you can just use your basic calculus. But in this class, we will only be doing A is constant, okay? Okay. Let's look at some other problems. Let's look at the ballistic equation. Here. The ballistic equation is where we take our vertical motion and our horizontal motion, and we use the fact that it's the same time. Do I have any questions at this point? Anybody? Yeah.
Further equation on our no time given equation, or further clarification.
Right. This is
the velocities. Are those only the absolute, or the total velocity, or is that velocity in the x direction, velocity in the y direction?
You can do this as separable.
Okay.
You can do this as separable. You can have Vy final minus Vy initial squared is equal to 2Gy delta y. And you can do Vx squared minus Vx initial squared is equal to 2Gx delta x. However, the really cool thing is, since we're using V squared, that can also be written in a more general form, V final squared minus V initial squared is equal to 2A times the magnitude of your delta x, where this is A. Where if this is a vector, this is a vector, and this is a vector. But the whole point of doing two-dimensional kinematics is that we separate things, okay? So always separate things if you can, okay? Always look at your x and y things independently, okay? So figure out what's happening in your, if you've got a ballistic problem, figure out what's happening in the y direction first, because this is where things are complicated. The x direction is simple as, it's just moving at a constant speed in a constant direction.